Hello, my name's Matt from Digital. Welcome to lesson 6 of the Coding for Climate Action Year 4 data logging unit of work. You know what you're doing by now, so let's scroll down, choose Year 4 data logging, have a look at the resources and get into this thing. Of course, I'm going to need the exemplar data logging journal so we can see just what it is we're expecting students to produce, and a reminder that they're going to have their own version of this copied in order to be actually be able to enter data into it. So lesson 6 is kind of a wrap up of the unit of work, but the core data logging thing that we're looking at is this idea of sound, which I think is a pretty neat way to end the unit of work and a little different way to think about data logging and the environment, right? So of course, lesson plan. I'm just clicking away, assuming you know what you're doing now. So apologies if this is the first video you're watching. I'm clicked on the teaching guide, the lesson plan, to kind of give an overview of this. So the teaching guide, of course, gives us the learning objectives for the lesson, understanding how sound can be used to monitor environmental change, understand sound levels, a type of input into a computing system. That's a key thing here, really. We think of inputs as being, buttons being pressed and kind of keys being typed and things like that. But actually, we can take in all different types of inputs: sound, temperature, so on. And to identify patterns of sound and data and infer environmental conditions. Okay, so more on that in a moment. Of course, we've got the national curriculum links, computational thinking links, and all of the resources and things that you might need for the lesson. Of course, some lesson prep as well. This lesson does involve going around using the microbit to log sound levels. Okay, that's the data logging that's happening. So, of course, some preparatory thinking about where you might want that to take place, and of course, warning teachers or other sort of staff members or other students in the school that we're going to have some year fours like going around and putting stuff in places that they wouldn't normally be found is kind of crucial, I would argue. So rest of the details for the lesson are in the teaching guide. So please have a look at that for more details. So let's jump into the lesson itself. Number one, before we get into the sound of climate change and the data logging of sound, of course, today is the last time we're going to be looking at our broad beans. So we spend a few minutes on that and a little bit more than just logging the data. So first of all, measuring the broad beans, right? And popping that into our broad bean growth tab here. So we can see mine is now in the final week grown to 7 centimeters. All right, we're going to have some broad beans for dinner soon. Fantastic. So that's my individual kind of record of the broad beans. As a class, we really want to think about what the overall results have been, right? Because we want to collect all of our data together to think about whether the initial data logging that we did was good enough evidence for where we should be placing broad beans. So as a class, we can think about what the averages were. So every student should have that average, and we might not have averages completely understood, but students can understand these numbers are bigger, that is theoretically better. Okay, so who had the biggest average light and temperature readings? Who had the best growth? Was there a correlation between the two? Theoretically, there should have been, right? But that might not be the case. So there's a nice areas we can explore there. Maybe there are other things that might contribute to better growth or not. Did we water them too enough or too much? Beans are going to grow to the sort of heightened area that they're going to grow to as well. They're all going to have natural kind of attributes that we don't know until we start growing them. So that might have impacted results as well. But so the idea here really is that data logging helps us find the best spot. But what we then do is important. We could have done continual data logging about measuring moisture and use that to help us. But of course, we need to be able to look at these plants and monitor them as well and think for ourselves. So kind of getting across that idea that data logging is really super helpful, but the humans making decisions and the actions we take are the important thing, really. It's not just the data logging, there's the humanity involved here as well. And that's especially important when thinking about things like the climate and making a better world around us. Cool, so that's our first activity, hopefully the first 10 minutes of the lesson or so, and then we'll go on and think about the sound of climate change. So a quick case study to introduce to students. Kate Stafford is an oceanographer a bioacoustician, associate professor at Oregon State University, and she has like an awesome job, which is monitoring kind of the sounds of climate change, for example, sounds of glaciers and things like that, or vocalizations of marine mammals, and then thinking about what those sounds actually tell her and therefore us about the changes to the natural world. That are happening and how we hear those. And this is really cool, I think, because often it's really natural to think of sensing the world around us in terms, especially climate change, in terms of what we can feel, maybe, or what we see or experience, but kind of excluding what we hear from that. Okay. And that's not the case. Climate change is something, and the world around us, of course, is something that's impacting us, and we're sensing all different ways. And whether it's sounds of climate or the sounds of cars, increased cars, being an indication of pollution and increased congestion and things like that, we've got all these different ways that we can think about how we monitor the world around us and therefore take action and try and be cool and have a better impact on the world. So that's the drive for the lesson, really, that we can think about listening to the world around us and use that to make decisions about how to make the world a better place. So here is and as such, the students are going to be doing that in this lesson. So here is the code that students will be using. A little bit more straightforward than the code that was used in the previous two lessons. So hopefully students will be able to pick apart, having read all this code now over the last 6 weeks, pick apart the fact that we have an OnStar icon and that as the program is running, it's logging sound level. Okay, so the input is the sound level and then it pauses. So we log the sound level and then pause for 5 seconds, log the sound level and then pause for 5 seconds. Let's see if I can download this to my microbit. So we have a think about what this code is doing. We can see there's some discussion points here. The forever loop means it's going to be working continuously. And think about where we could use this and why, right? Think about how it could be used in an impactful way. Noise pollution, quiet zones, tracking sound changes in nature, for example. And then having thought about that, choose where we can use this in our school environments and why. If this was me, I'd have had one of these pre-selected and kind of made it feel like the students get to choose, but actually I've already decided where we're going to be using this. So some ideas about how we could use this with environmental kind of principles or climate principles in mind. Okay, so mine is logging sound now, fantastic. So having looked at these, we choose an area for them to go and then actually place our microbits there to do some sound logging. Before we place it there, or when we place it there and when we come back to classrooms, make some predictions about what the sound data will look like. Okay, what it will do. Will it be quiet all the time? Are there going to be movements in the sound level in our chart? Are there going to be real notable changes in the chart? Will it be loud all the time? What do we think the data is going to look like? How is it going to present in the chart? And why do we think that is the case? Okay. It's up to you how long you want to leave the microbits in their location for. And of course, we need to think about what we're collecting. So if it's over before, during and after break time, or in a classroom, or near the road, collecting car data, it will kind of dictate how long you want to leave the microbits out for. So it might be you want to go away and do some other learning and then leave the microbits there and then come back to this next section later on. But having collected our data, okay, let's say I've collected my sort of minute or so of data. We plug our microbits back into our computers, and you won't see the pop-up folder, but it's there, I promise, which gives us the My Data folder, which then shows us, there we go, the sound level over time. And you can see mine is going up and down, probably got something to do with me talking as I'm holding it. So we, of course, copy and paste this into the the data logging journal and put it into lesson 6 here. So here's some stuff that's pre-done and we can see the changes over time here. So that's populated my sound level there. Having done that, the students can then answer some questions describing the sound change over time. Is there a big change or not? What caused it? What could be done then, importantly, to reduce sound levels in that location? Okay, because we can think of sound levels as being something that's maybe impacting the world around us in a way that we don't necessarily want it to be done. Okay, whether that's for our well-being or for wildlife that's being disturbed or things like that. We can relate it to the well-being of us humans or other natural kind of phenomena elsewhere. There we go. So that is all that. And then, of course, answering the questions is what I've just talked about. So that wraps up that lesson. And then the final activity for the whole unit of work is thinking about the learning that has been done. So if we look at this lesson 6 wrap up, and again, we'll need individual copies of this either printed and handed out to students, or they can have their own copies. We kind of go through the different skills that have been explored, to a reflection on the whole unit of work, the different skills that have been explored over the unit of work, and then the different lessons that they've experienced, okay? And then the kind of careers that link together the lesson, well, the careers that the skills link between the lesson and the careers, if that makes sense. So we want students to reflect on these different skills. What skills of here did I use in each lesson? Did they think they used? And then think about how those skills actually relate to any potential careers that came from that lesson. So plant growth and tracking was lesson 2. Did I collect data and record? What's the main skill I used? Analyze pattern and trends. Did I make predictions, so on and so forth? So I'd say, plant growth and tracking, data collection and recording was the skill I used. So I'd put that in this box here. And I'd be like, okay, cool. So I now know that actually that's a skill that can be used for like agricultural scientist or botanist or things like that. So trying to make a real link between what we're learning, the skills we're learning, and actually how that relates to real life careers. And kind of made that point through the videos that it's kind of cool to be letting students know there's a wider world about what we're learning here, that we're kind of directing students to, if it's the right thing for them. And that will end the unit of work. The final thing to kind of just remind and point out is at the end of the unit of work, if this slide is here, please take a moment to do the post survey. That should say post, not pre. But there we go. I'll change that. Will be changed by the time you next see it. But the links are correct. So please get students to fill out this really quick survey. And if they've done the one before and the one the pre-survey and the post-survey, it will really help us know what the impact of this unit of work has been. And same for you as well. Good teachers, please, if you could fill that out, that would be brilliant. It helps us get more funding, helps us show the good work that we are hopefully doing, and helps us think about how we can do more stuff like this and how we need to do things better in the future. Thanks so much for being part of these tutorial walkthroughs. I hope the lessons have been really useful. I hope the kids do enjoy them. And I'll see you on some other videos or some other events another time. Take care. Thanks again.